Hello, for this lesson, we're going to be covering another topic still under real numbers, which deals with ratios, rates, and proportions. So, according to the syllabus, mostly that part of that is covered in Form 1, Form 2, all the way to Form 3. So, mostly then looking at the Form 3 part of the O-level syllabus, ratios, rates, and proportions. So, for reference sake, if you have the new general mathematics book, book 3, that's in chapter 23, and in the mathematics today book 3, that's in chapter 6. So ratio is a way of comparing one part of a whole to another, and it can be expressed as a fraction or as a whole number, or as a fraction of the whole number, or as whole numbers. And we often use ratio when we're trying to show how things are shared in any situation where we might use cofactors. So for example, if a pizza was sliced into 8 pieces and shared in the ratio 6:2, so let's say we have a pizza and then we cut it into 8 pieces, and then one person takes 6, so that's 1, 2, 3, 4, 5, and 6. And another person takes 2 of the slices, 1 and 2, right? So that gives us 6:2. When you look at it, the whole is 6 plus 2, which is 8. And 6:2 can further be simplified by dividing both sides and dividing both by 2 and by 2, we get 3:1. So that means that we can express the ratio 6:2 as 3:1, and it's still, even though we still have 8 slices, right? So for example, we have a question which says some money is shared between Amber and Beatrice in the ratio 8:12 respectively. Simplify this ratio. So to simplify the ratio, we have 8:12, and we know that the highest common factor is 4 for both of these. So we're dividing both sides by 4 and by 4. That means that the ratio is maintained, and that's going to be 2, and that's going to be 3. So that's 2:3. Right. Then it says, find the fraction of the money that each person receives. Give your answer in the simplest form. Write the total number of parts, right? So for fraction, we have figured out that they have 8:12, right? That means that the total number of parts is going to be 8 plus 12, which gives us 20. And when we look at it, Amber receives 8 parts of the 20. Simplifying this, 4 into 8, that's 2. 4 into 20, that is 5. So 2/5. Right. Then Beatrice, we know Beatrice received 12 out of the 20. Again, 4 into 12, that's 3. 4 into 20, that is 5. This guy is going to be 3/5. And that is then the ratios of what they get is the same if we had used, because we'd simplified 8:12 to 2:3, which would be the same as saying Amber gets 2 plus 3, that's 5, which is still what we got. So Amber, and then Beatrice would get 3/5. So that's the same, either in the simplified form or in the original form, we get to the same answer. And then now the second example says Ahmed, Batuk, and Chand share $1,000 in the ratio 8:7:5. Calculate the amount each receives. So we have Ahmed. So the order is important. The order that they are mentioned is the order at which the ratios appear. So Ahmed is the one who is represented by 8, Batuk is the one represented by 7, and then Chand is the one represented by 5, right? So first things first, we need to find the total to see what the total is going to be. So we have 8 plus 7 plus 5, right? And 8 plus 7, that's 15, plus 5, that's 20. So now, calculate the amount each one receives. So then, Ahmed is going to receive 8 out of the 20 pieces, just like almost in the pizza slice, of the $1,000. So times 1,000, right? And that gives us $400. And then we go to Batik. That's the second one. So that's 7 over 20 times the $1,000. And that's going to be 350. And then we go to Chand. That's 5 out of the 20 times 1,000. And that's 250. So if you have time, you can also cross-check to make sure that it actually adds up. So then the total should add up to $1,000, right? Because we know that the $1,000 was shared among the 3. So then the total should add up to 1,000. So if we add 400 plus 350 plus 250, that is in fact going to give us 1,000, because 400 plus 350, that's 750, plus 250, that's 1,000. So then it would have proven that these are also correct. So just to cross check and to make sure, you can use that as proof. Okay, great. Question number 3 says, write the following ratios in their simplest form, right? So we have 115 centimeter is to 1,5 meters. So the first things, number 1, put both sides of the ratio to similar units, right? Because when you look at it, we have meters on this side and centimeters on this side. So in this case, I'm choosing to change the meters to centimeters. So firstly, we have 1.5 meters to centimeters. So 1 meter is equal to 100 centimeters. So if 1 meter is 200 centimeters, so I prefer to use proportion in terms of unit conversion, then 1.5 meters means more. So then I invert this side of the equation such that I have 1.5 over 1 times 100, which will give me 150 centimeters. So now I have 115 centimeters is to 150 centimeters. Now that they are both centimeters, I don't have to include the units, so that can also be the same. But dividing both sides by 5, because that's one of the factors that I can think of for a start. I might have to do this repetitive in case 5 is not the highest common factor, but I'm starting with 5 because I know that it's divisible in both. 5 into 5, 1. 5 into 11, that's 2, remainder 1. 5 into 15, that is 3. 5 into 5, 1. 5 into 15, that is 3. 5 into 0, 0. So then it's going to be 23 is to 30. And there is no other common factor going into this. So this will be the answer. So that's the ratio in the simplest form. And then the next one, we have 1 over 3 is to 5 over 8 is to 3 over 4. So again, in this case, we find the lowest common multiple in all cases. And so finding the lowest common multiple, so we have the denominators. Our denominators are 3, 8, and 4. So what is the lowest common multiple, right? Again, from the previous video where we did lowest common multiple, we can have 3 in its prime factors. 3 into 3, that's 1. So that's just going to be 3. Then we have 8. 2 into 8, that's 4. 2 into 4, that's 2. 2 into 2, that's 1. So 3 is just 3 times 1. 8 is equal to 2 times 2 times 2. And 4, 2 into 4, that's 2. 2 into 2, that's 1. So 4 is equal to 2 times 2. So we have now 3 is equal to 3. 8 is equal to 2 times 2 times 2. 4 is equal to 2 times 2. Therefore, lowest common multiple is equal to 3 times 2 times 2 times 2. 3 times 2, 6 times 2, 12 times 2, that's 24, right? So we know that 24 is the lowest common multiple. Then the second part is to express fractions in the lowest common multiple denominator. So in this case, we have 1 over 3 is to 5 over 8 is to 3 over 4. So 1 over 3 over 24, 3 into 24, that's 8, times 1, that's 8. And then 8, or 5 over 8, 8 into 24, that's 3 times 5, that's 15. And then 4, 24, 4 into 24, that is 6, times 3, that's 18. So as you can see, we have a common denominator, so that can then be simplified in that same aspect. So then the next couple of questions, you can try this exercise, which is extracted from the Mathematics Today textbook. So the first one, it's just mostly to simplify these ratios in their simplest form. So in this case, sorry. So in this case, like I mentioned, it requires you to put them, for example, for number 1D, in the cent units, because we have dollars and we have cents. So just watch out for examples like that. And then number 2, express each of the following ratios in the form 1:n or n:1. And then part of that is dealing with fractions. Then number 4, in each given quantity, find the larger part if the quantity is shared to the given ratio. So yeah, we have the different expressions. So you have to know that, for example, 3:7, the bigger part is going to be the 7. So yeah, you can take a screenshot or pause and attempt these. And then number 6 says three business partners, Kumbi, Vuma, and Zippo, shared the profit in the ratio 6:7:2. If Vuma received 4,900, how much did Zippo get? Find the total profit shared. So yeah, looking at those, and then also the second exercise are more examples that you can give a try. And you can, if you have any questions, feel free to reach out to me. So then the next part talks about decreasing ratios. For example, the selling price of a second-hand car is originally 8,190. The dealer reduces the price in the ratio 11:13. What is the new selling price of the car? Right. So we have, so it was reduced. That means that the smaller, so we have 11:13. That means that the original is, because, okay, that means that the original is smaller, right? Because it was reduced. So that means that if the original price is higher, then this is the original price and the new price. So if new is to original is 11:13, which is the same as saying, again in the same order of new is to original, knowing that we let the new price be X because we do not know what what the new price is, and the original price was 8,190. So you can choose to do it one of two ways, either expressing it as fractions. So 11/13, that's just new over original. Should give you the same ratio as new over original when it comes to dollars. And then you solve for X using the method of subject of formula. We want to make X subject of formula. So that means that 8,190 crosses the equal sign and multiplies since it was dividing. So that means that X is equal to 11/13 times 8,190. And when you multiply that out, you get $6,930. And that's the answer. So when you decrease ratios, you equate the value you have to the higher number in the ratio. So because now decreasing means the original value was much higher, so it would take the higher ratio. So that's why in the example above, if the car was going for 8,190 and got reduced, the new price equals to the lower part of the ratio, which is 11. And then with increasing ratios, it's the opposite, except you equate the value to the new value to the higher part of the ratio, right? So an example says, find the result of increasing 75 centimeters to the ratio now 9:5. So again, we have old is to new, whichever order you prefer, you have to maintain that. So it was increasing, right? Which means that the odd has to be the smallest one. So 5 is then the odd. So 5 is to 9, or maybe let me keep it in the same order as in the question. So we have new is to old, because new is now the higher. 9 is to 5 is equal to new is to old. So in this case, we do not know what the new price is, what the new size is, but the old we know is 75 centimeters. So again, as ratios, new over old, which is 9 over 5, is the same as saying x over 75, because that's new over old. You maintain the order. Make sure to maintain the order. Again, to make x a little formula, 75 crosses the equal sign and it multiplies since it was dividing. So times 75 is equal to x. So x, which is the new measurement, is going to be 135 centimeters. So that means it increased from 75 centimeters to 135 centimeters. And that is the new size. And then the next example says increase 5.4 centimeter in the ratio of 5:8. So it says increase. So again, that means that this is the old, and this is the new. Again, we maintain the order we have in the ratio. So that means 5:8 is equal to 5.4 centimeters is to x, which we're trying to find the new length in this case. So 5/8 is equal to 5.4 over x. So we make x up to the formula by making it cross the equal sign, then it multiplies. So that means 5/8 times x is equal to 5.4. But then we now have to have this fraction cross the equal sign by inverting it. When it crosses the equal sign, it's inverted. So that means that most of making substitute formula will be covered in a separate topic. X is equal to 5.4 times 8/5. And then when we compute that, we get 8.64 centimeters as x. That is the new length. And that's an example. So you can try this exercise, which says a trader increased the price of an item in the ratio 11:5. Find the new price of an article which was marked at $275. So another example says a bag contains yellow balls, pink balls, and green balls only, right? So that means that the fractions have to add up to 100% or to 1. The ratio yellow balls, pink balls, and green balls, again, the order is important because now we know, in reading that part, we know that yellow is 7 of the total. Pink is 3 of the total, and green is 5 of the total. Right, just by reading that. There are 42 yellow balls in the bag. Work out the total number of balls in the bag. So on a fraction perspective, we need to first find what the total number is. So we're told that the balls are 7:3:5. So the total is going to be 7 plus 3, 10, plus 5, 15, which is equal to 15, right? First thing, get the total. Second thing, ratios. To remember what you have. So we have yellow being 7/15, pink being 3/15 and green being 5/15, right? Then the next part says, well, I'll cut the total number of bags. So now the calculate total number of bags of balls. So we're given already that there are 42 yellow balls. So we know that yellow is 7/15 of a total balls, or the total number of balls, right? So let total be equal to x. So yellow is 7/15 of x, and that's equal to 42. So we just need to find what x is. Again, making x a little formula. 15 crosses the equal sign, it multiplies, so it's going to be 42 times 15. 7 crosses the equal sign, it divides because it was multiplying, and then computes that, we get 90 balls in total. And that's how you do that. Then we have another example which says 3 business. Oh, this I think I had let me just cross check. It was supposed to be one of the worked examples. Okay, yeah, it is in one of the exercises, so you can try that. And then you can also try the next example, which talks about how Nadira has some t-shirts that are either white or blue or green. The numbers of the t-shirts are in the ratio white, blue, green, which is 5:4:1. 48 of the t-shirts are blue. We call the total number of the t-shirts. And yeah, so give that a try. Is one of the exercises from this subtopic under ratios.